Hello, this is Mr. Brooks, and welcome to Lesson 8.3, the tangent ratio. In this lesson, we're going to learn the tangent ratio to determine side lengths in triangles, and we're going to use the tangent ratio to estimate the distance to a distant object, as in example 2. Now, in the last lesson, we learned how to calculate side length of special right triangles, particularly 45-45 90s and 30-60 90s. But what if the angles we know are not 45-45 90 and 30-60 90? We know it's a right triangle, but the other two angles are not those special right triangles. Well, in that case, you're going to use a special family of ratios called the trigonometric ratios. And the first trigonometric ratio we are going to study is called the tangent ratio. And the tangent ratio is defined to be the opposite leg over the adjacent leg. And let me explain what that means. So let's say we have triangle ABC, and we're trying to find the side opposite angle A. Hopefully you will understand the side opposite angle A would be segment BC, and the side adjacent angle A would be segment AC. We're not talking about the hypotenuse when we say the side opposite. We're talking about the legs. Alright, so again, if we're talking about angle A, then segment BC is opposite, and if we're talking about the side adjacent angle A, we're talking about segment AC, which would be adjacent. Now let's talk about angle B. What's the side opposite angle B? Hopefully you would agree the side opposite angle B is AC, and the side adjacent angle B would be BC. Make sure you understand opposite and adjacent, or you've got no chance at trying to figure out the tangent ratio. Again, tangent is defined to be opposite over adjacent. Let's begin with example 1, triangle TUV. We're trying to find the tangent of angle T, which you are simply going to write tangent of T, which is going to equal opposite over adjacent, which is going to equal T, the opposite side is 3 of T, and the adjacent side is 4. So the tangent of T would be 3/4. Tangent of angle U, opposite over adjacent, would be 4/3. Quick check number 1 asks you to find the tangent ratios for angle J and angle K. Please pause the video while you try to figure this out. First, let's look at the tangent of angle K. Remember, tangent is opposite over adjacent. So, opposite of angle K would be 3/7. Tangent of J would be 7/3, opposite over adjacent. Part B says, how are these two related? Hopefully you agree they are reciprocals of one another, or inverses. Now let's look at example 2. Let's say that you're skiing in Bryce Canyon National Park and you see a distant cliff far away. You want to try to figure out how far away is the cliff. By the way, Bryce Canyon National Park is in Utah. Of course you can't measure the distance to the distant cliff. But what you can do is form a giant triangle, as in the drawing at the left, and you can measure 50 feet at a right angle. Now these angle measures you can get with a pretty easy device, which I will show you in class. So you can get the big angle measures. Of course you can't get a giant protractor out there, but I'll show you a device that you can use to create to get the angle measures. Now let's say we take this device and we measure angle 1 to be 86 degrees. How are we going to get the distance from you to the faraway cliff? Please pause the video while you try to figure this out. Alright, here I have redrawn the triangle. Again, we got a right angle and we got an 86-degree angle. We're trying to get x, the distance to the faraway cliff. Well, we know that tangent of 86 degrees is going to equal opposite over adjacent. Opposite is x, your adjacent is 50. So to solve this, you're just going to multiply both sides by 50. So 50 times the tangent of 86 degrees equals x. Then you're going to plug exactly that into your calculator, and you will get x to be approximately 715 feet. And I will make sure you are plugging that into your calculator correctly. Quick check number 2 asks us to find the length of the missing side based on what's given. So please pause the video while you try to figure out A, B, and C. For part A, the tangent of 54 degrees is going to equal W over 10, opposite over adjacent. Now we're going to multiply both sides by 10, and we get 10 times the tangent of 54 equals W. And you're going to punch this into your calculator, and you will get W to be approximately 13.8. By the way, if you do not get 13.8, that means your calculator is in radians instead of degrees. You need to always check and make sure your calculator is in degrees. To check to make sure your calculator is in degrees, hit the mode button on your calculator, and the third one down will give you the choice between radians and degrees. Now let's look at part B. Tangent of 28 degrees equals opposite over adjacent, so it's going to be 1 over W. Solve this, the first thing I do is multiply both sides by W. So you get W times the tangent of 28 degrees equals 1, because your W's cancel. Then you're going to divide both sides by the tangent of 28 degrees. And that's not going to fit, but divide both sides by the tangent of 28 degrees, and you get W to be approximately equal to, sorry about that, W approximately equal to 1.9. Now for part C, there's actually two ways we can do it. First way, we can say the tangent of 57 equals W over 2.5, and when you multiply both sides by 2.5, you're going to get W to be approximately equal to 3.8. The other way to do part C, to get W, would be, say, the tangent of 33 equals opposite over adjacent, which would be 2.5 over W, and then you'd multiply both sides by W and divide both sides by the tangent of 33, and so W would be 2.5 divided by the tangent of 33, which again better give you approximately 3.8. Now next, now that they've given us angle measures and want us to get the length of the missing side, of course now they're going to give us the sides and ask us to find the measure of the angles. To do, whenever you're looking for the angle measures, you're always going to use the inverse function on your calculator. Since we're working with tangent, we're going to be using inverse tangent. Alright, let's look at example 3. They give us the length of three sides of a triangle to be 6, 8, and 10. We got to find the measure of x to the nearest degree. So the tangent of x is going to equal 6 over 8. And you're going to punch into your calculator inverse tangent of 6 over 8. And then when you hit enter, you're going to get that to be approximately 37 degrees. Again, I hope you're actually doing this instead of just looking at it Actually punch that into your calculator, make sure you get the right answer. Inverse tangent of 6 over 8. And make sure you get approximately 37 degrees to the nearest degree. Alright, let's try quick check number 3. Okay, on this one they're asking to find y to the nearest degree. So the tangent of y is going to equal opposite over adjacent, 100 over 41. So now what we need to plug into our calculator, y is going to equal inverse tangent of 100 over 41. So we punch that into our calculator and we get y to be approximately 67.7 degrees, or to the nearest degree 68 degrees. This concludes lesson 8.3.